Now students, today we will learn the chapter of 12th standard and which name is three-dimensional geometry. Now we can start the chapter which name is three-dimensional geometry. First, I tell you my name. My name is Dixit Chintaman Lakshman Rao from Siddheshwar College, Mazalgaon. Now our chapter is three-dimensional geometry. It is very important chapter of 12th standard. Now you have heard the word dimension. So what is meant by dimension? First we discuss the word dimension. Dimension means, just like in general we can say shape of any objects, but in three-dimensional geometry, dimensional means it has three important points. First, length, breadth, height. It is also called as width. So this is considered in dimensional. So in three-dimensional geometry we have to learn, but before this we see some important dimensional figures. You know, the first dimensional figure, just like as this is cuboid. Now this is the cuboid. Now here each figure has height h, each figure has width, and it has length. So this is the figure of three-dimensional cuboid. Next, or we can say cube. Cube is also a three-dimensional figure. Just we can say that we are living in three-dimensional. In our hall, this is our three-dimensional. So what is the purpose of this three-dimensional geometry in our mathematics, that we have to see here. So first, this is the dimensional, means we have to consider here 3 points: height, length and width. So that's like cuboid or cube are the shapes of that dimensions. So in this chapter, three-dimensional geometry, in this chapter we have to learn about mathematics which used in geometry. So let's start first the figure. Now in three-dimensional geometry we have to discuss the first three definitions first of all. The first definition is directed angle, direction cosine. First we clear this definition, directed angle and direction cosine. So for that we draw a figure just like Now in two-dimensional we have seen x and y axis, but in three-dimensional geometry there are three axes, x, y, z. Now this is a origin. We can draw the line passing through O. Here is P. Similarly, it passes through P dash. Now here we can also consider the line L. We can also consider the line L. Then what happens? This x-axis, y-axis, z-axis means this is three-dimensional, this is width, this is length, and this is our height. Now here, that OP line creates the angle. So first is that angle is alpha. Now next, that y axis that creates angle beta, and OP line that's create angle gamma to z axis, and that L line, this L line is parallel to that OP line. So here OP line creates the angle x axis alpha, creates the angle beta y axis, creates the angle gamma z axis. So this line creates three angles, that is alpha, beta, gamma. That angles are called as directed angles. Now the line OP makes an angle. The line makes an angle with x, y, and z axis are alpha, beta, and gamma. Then these angles are called as a directed angle. These angles are called directed angles. Now similarly, OP makes angle alpha, beta, gamma with x, y, z axis, but here that L is line parallel to OP means that L line is also make the angles alpha, beta, gamma to x axis. Means that any line parallel to that OP line that also makes the angle alpha, beta, gamma to x axis. So this is called as directed angles. Okay. Now here is three-dimensional. First I will also explain that this is x axis, this is y axis, z axis. Now this is three-dimensional. That is our length, that is our width, that is our length. This we have discussed first startly. So here that OP lines make alpha angle, OP line makes beta angle with y axis, that OP lines make gamma angle with z axis. The three angles are called as directed angles, and L line is parallel to that OP, so we can say that L line also makes an angles alpha, beta, gamma to x axis. So that alpha, beta, gamma or angle made by the line, is called as directed angle. And so that L line is also make the angles, because why? Because OP is parallel to L, so that alpha, beta, gamma are called as directed angles made by the line L. Why? Because that two lines are parallel. Okay, so this is the directed angle. So next is we see direction cosine. Now in generally we know all trigonometric functions. So what are the trigonometric functions? Sine, cos, tan, cot, sec, cosec. So here direction cosine. So what is meant by direction cosine? So here we also call cos as cosine. Cos, generally we say cos, but it is actually cosine. So we have to calculate the cosine of that angle is called as direction cosine. We have to calculate of that cosine angle of that alpha, beta, gamma is called as direction cosines. So what happens? So here therefore we can say that here cos alpha, comma, cos beta, comma, cos gamma. So that cos alpha, cos beta, cos gamma means cosine alpha, cosine beta, cosine gamma are called as direction cosine of the line. And it is denoted by L small m n. It is denoted by small l m n. That is, we can write here L is equal to cos alpha, m is equal to cos beta, and n is equal to cos gamma. Means that cosine of angle which creates by line are called as direction cosine of that lines. So in these 2 points it is clear that alpha, beta, gamma are called as directed angle, and that angles of cosines, that is cos alpha, cos beta, cos gamma, are called as direction cosine of that line, and it is denoted by small l m n. That is, L is equal to cos alpha, m is equal to cos beta, and n is equal to cos gamma. So we have clear that two definitions, directed angle and direction cosine. Now we will see some examples from that. But before this, we see what are the direction cosines of x, y and z axis. So here we clear some remarks. So that axis x, that is y, and that is z, means that x axis creates angle 0 degree. Now y axis create angle 90 degree, and that z axis create angle 90 degree. Remarks we have to see, x axis creates itself 0 angle. Now it is perpendicular, that is 90, and it is also perpendicular 90, means the directions cosines of x axis are, that is L is equal to cos alpha, m is equal to cos beta, n is equal to cos gamma. So therefore L is equal to cos 0, m is equal to cos 90 and n is equal to cos 90. So we have the value of cos 0 is 1, cos 90 0 and cos 90 0. So therefore the direction cosine of x-axis, direction cosines of x-axis are 1 0 0. This is our first remarks. Direction cosines of that x-axis are 1 0 0. Now second remarks, what will be? Now here that y-axis means its itself angle is 0. Now that z, its angle is 90 and that x, its angle is 90. Therefore cos alpha m is equal to cos beta, m is equal to cos gamma. So here here angle first it is 0, sorry, it is 90, it is 0 and it is 90, because y-axis, this is x, it is 0 and it is 90, so it is 90, so it is 0 and it is 90. So therefore L is equal to cos 90 0, m is equal to 0, m is equal to 1 and n is equal to 0. Means the direction cosine of y-axis are 0, 1, 0. So that are the direction cosines of that y-axis. And last number third, direction cosine of z-axis are, means z-axis, that are the angles created first 90x, x-axis 90, that is y 90, and z-axis itself angle is 0 degree angle. So here, so 90, so here is also cos 90 and so here is 0 degree. So this is 0, this is 0 and this is cos 0 value is 1. Therefore direction cosine of z-axis are 0, 0, 1. So that are the remarks for 3 axes. Direction cosines of x-axis are 1, 0, 0. Direction cosines of y-axis are 0, 1, 0. Direction cosines of the z-axis are 0, 0, 1. So this is for only understanding. Now that two definitions, we have to see some important examples which may be asked in our examination. So first we will see how that examples. I write here a line makes an angle if a line makes an angle, if a line makes an angle 90 degree, 135 degree and 45 degree with x, y, z axis respectively, then find the direction cosine of the line. Then find the direction cosine. We can also write this is as direction and cosine, direction cosine of the line. So here we have to find the direction cosine of the line which makes an angles 90, 135 and 45 with x, y and z axis respectively. So first, how it is solved, we can solve it. We have given line makes an angle, alpha is equal to 90 degree, so that is beta is equal to 135 degree, and gamma is equal to 45 degree with x, y and z axis respectively. That we have to given. Now we have to calculate the cosine of that angle, and this is called as direction cosine. So now here we have L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. So here we can put here L is equal to cos 90 degree, comma, M is equal to cos 135 degree, and N is equal to cos 45 degree. So we have to calculate the angle of cos 90, cos 135 and cos 45. So here we have to use the allied angle formula. So listen first that L is equal to cos 90. For some time we can write as it is. Now here M is equal to what? That is cos 135, means we can write here cos 180 minus 45, and that is, and N as it is equal to cos 45. So here we have used allied angle formula, that is we can write here cos of pi minus theta is equal to minus cos theta, we have to use here. So is equal to cos 90, so that is M is equal to, means minus of cos 45 degree, and that is here N is equal to cos of 45 degree. Now we can calculate, and we know all that angle L is equal to cos 90, so that is 0. M is equal to cos 45, means 1 by under root 2 minus as it is, and N is equal to 1 by under root 2. So that L, M, N are called as the directions cosine of that line which makes an angle 90, 135 and 45 with x, y and z axis. So right, this lastly we can write here the line makes an angle, the line which has the direction ratios, direction cosines are direction cosine are 0, minus 1 by under root 2, comma 1 by under root 2. Now this is finished. Just we have solved that example. So many types of example we can solve as like. Now next we can see second example. Only I will change here the angles. Now what are the angles? Now the line makes an angle 60 degree, 125, 120 degree and 150 degree with x, y and z axis respectively. Find direction cosine of the line. That is our second example. So in short, how we can solve it? Just like CET, just like MSCET, just like JE. In short, how we can solve here? So firstly, we have to put here, we make it shortly for our CET or for our JE. So how can we make it short? Alpha we have to given 60, beta we have to given here 120, and now gamma, we have to given here 150. So we have cos alpha, m cos beta, n cos gamma. So here put L is equal to what? Cos 60, m is equal to cos 120, n is equal to cos 150. So this is L. Here we have to use the right angle formula. So m. So what we do here, cos 90 plus 30, here cos, what we do here, 180 minus 30. So this becomes L is equal to, as it is, cos 60. Now here m, cos of 90 plus theta means minus of sin theta, and that cos pi minus theta, what is my pi minus theta? That is minus of cos theta, minus of cos theta. So our answer is so that is cos 60, L is equal to 1 by 2. So that is sin 30 means minus 1 by 2 minus, and that is cos 30 is equal to minus of under root 3 by 2. Therefore, the directions cosines of the lines are, that is 1 by 2, that is minus 1 by 2, and that is minus of under root 3 by 2. In short, we can solve just like as. So many examples we can solve from this. Only we have to change angle, that 60, 120 and 150. We have to only change angle and it will be change the direction cosines. So this is very important points. So many examples we can solve that from this. If in our textbook so many examples are given as like this, so you can study yourself. Now we can see next point, relation between, what will be the relation between direction cosines. Now the next point is now we have see directed angle direction cosines, and from that we have taken examples. Now we have to see next point, direction, relation between direction cosines. So just we have see L, M, N are called as direction cosine of the line. So what will be the relation between them, that we have to see, and it is important for us. Now our heading is that relation between direction cosine of line, relation between direction cosine of line, relation between direction cosine of line. So it is important point. So we know the direction cosines L, M, N are a direction cosine of the line, but what is the relation? So that relation we have to see one more important theorem. So which is that theorem? So first we write that theorem. Now theorem number first. If L, M, N are direction cosine of the line, a direction cosine of the line, then L square plus M square plus N square is equal to 1. From this theorem, we clear that the relation between direction cosines are L square plus M square plus N square is equal to 0. This is a relation between direction cosine of the line. But how it is? So we can see from this theorem how it is. Okay. So what is the proof of that theorem is very important to us. Everybody has known this proof, how it is. So first we draw the figure of that. Now here origin x, y, z axis. Now here we draw the line L. This is L dash. So that is, here we take a point P. Now the distance is r, OP distance is r, and P is a point in three-dimensional geometry, means it has 3 points. That is, first x belongs to x-axis, y belongs to y-axis, and z belongs to z-axis. That OP distance is r, and we take the line AB which is parallel to that AB line. So that line L makes an angle x-axis with alpha. That line OP makes an angle beta with y-axis, and that line makes an angle gamma to this z-axis. So this is our required figure. So in this figure, what first we see, this is x, y, z axis, that line L, the point P on the line OP that has coordinates x belongs to y, x-axis, y belongs to y-axis, z belongs to z-axis, and that OP distance is r. That AB line is parallel to that L line, and that L is that OP, that L line is also processing and carry as like L dash. Okay, so this is our required figure. So first we see the complete proof of that theorem because it is important. So first we consider a line. Consider a line L passing through point L passing through point origin and parallel to line AB, and parallel to line AB. Just we have discussed first, and then we can write here. Now let the point L, P is the point on the line L, the which coordinates are x, y, z, and then length of OP is equal to r. We consider here length of this gives equation number first because it is used for next point. Now the position vector of the point, the position vector of the line OP is the position vector of the point of the line, position of the position vector of OP is position vector of OP is OP bar is equal to, so that is that her coordinates means x I cap plus